Hey everyone, and good evening. Welcome to PHP Performance Tuning with John Pereira of Gapstars, where we will be learning about identifying bottlenecks and resolving them in a web application. Thank you so much for joining us today. We will be jumping into our session shortly, but first, a quick introduction to our presenter, John Pereira, who is a software architect here at Gapstars and Rentman, where he specializes in web tech. So without further ado, let's jump right into our session. John, the floor is yours.
Hey everyone, good evening. Thank you for joining us. I'm just gonna quickly share my desktop and we can get going. So this is going to be PHP Performance Tuning, tools, tips, and techniques. So the audience here are generally people on the SSC or like lead level. This is some feedback that I've been getting during even my interviews. I've been interviewing a lot of people, mostly software engineers, SSCs, leads for PHP and other web-related positions here at Gapstars. And sometimes I see people who are really knowledgeable in their areas, but the problem-solving tools and the approaches aren't there. I think that would really help round out people. And this is what the session is going to be about. It'll be about 45 minutes, and we'll be covering a few tools. So a little bit about myself. I am a software architect at Gapstars and Rentman. Been here for about a year, but I've been in tech for over 15 years, and in that time I've been mostly working with APIs and web technologies. I've also dabbled a little bit on the application side, but most of my experience is in services and dealing with the web. You guys can find me on Random Coding, where I just mostly talk about things that I'm working on. And of course, given the name, it does have a lot of other random stuff in there as well. And if you want some, to reach out and chat with me or something like that, I'm on Twitter. And all of the code that I just demo here is available on this GitHub repo. It's not much in there. It's a Laravel application, but if you find it useful, you can go ahead and grab it. So these are the topics we'll be covering. Bad app is just a really bad application that I made up. It's made in Laravel. I think a lot of people would be familiar with Laravel, but all of these techniques are, convertible to any language, a framework, as long as it's in PHP. Some of the tools that we're using here is specific to PHP, but the techniques themselves, there are other tools that will translate across to other languages if you want to check them out. We'll be looking at why load tests are important and quickly just setting something up. We'll also be looking at the Xdebug profiler. I think some of you would have worked with the Xdebug debugger, but I haven't really seen anyone use the profiler as much. And that's a really, really useful thing to have. And how to read the output of the Xdebug profiler. And then we'll also be covering a little bit of MySQL slow queries. So let's get going. This is the application. So this is available on the repo that I mentioned earlier. It's a simple API. There's no front end, nothing. It basically has 2 entities and 6 endpoints. You can retrieve all of the messages. And the structure is that there exists a user, and a user can post a message, and then a message can be hearted. So it's 3 tables: users, messages, and hearts. And hearts is kind of like a link table with the date on when a message is hearted. So you can basically just test it out. It just gives you some like a API response. This is on my local, obviously, so with Zoom and everything running, it's a little slow. I also have it running on Beanstalk. Just give this a little time. All right, let's just, it's a tech session without a little bit of funky errors, right? So there you go. All right, Oh no, I had to switch the server. There you go. Yeah, here it is. So it just gives you information on the user, the message that was posted, all of this generated using Laravel's Faker package. So it's all this auto-generated kind of random nonsense, but it'll help us with debugging and kind of looking at some real data. So there's about 2,500 users, 5,000 odd messages, and about 5 to 7,000 odd hearts in here that are populated. So given that everything is running locally, we don't need the local one anyway, so we'll just run it on the live one. So now you have an idea on what the structure is, right? So I think this is, if this even failing on the machine with Zoom running is actually a great example of why it is important to do actual load tests, because up to this minute while I was checking things, it is working fine. But then once I start running things on this, once I start sharing screens, it just fails. So if you take that to like a live web server example, what happens is that everything works fine on your local network. You don't have network delays. You don't have concurrency issues because it's always one user testing things. And that's the problem, because you all know once you go live, you have many users coming in, many users requesting for the same resources at the same time. If your application is reading or writing to a file or something in there, and what happens if 10, 15, 1,000 users come and request for data from that file, or want to put data into that file or database at the same time. Databases, of course, are completely fine with handling these kind of concurrency issues. They're built for it. But what about API requests outside to, say, a payment gateway or to an external API? That becomes problematic, and that's not really something that is tested unless you do load testing. Because what happens is it goes from testing on one machine on a local environment to production, and usually with nothing in between. And then the moment people come in on board, at the same time, it crashes. I think we've all faced this recently, actually a couple of, I think when COVID started, when you're getting on Keels or, any of these other shopping sites to order groceries, system crashes. And that's not really anything to do with the fault of the system itself. It's just that they're just not tested for that. So you then come up with solutions like a queuing system to kind of deal with the massive load or other solutions, because these systems are not really made for those kind of spikes that we're looking at. And it's always a good idea to find out where your system lies in this spectrum. To is it 10 users concurrent that you can handle, 100,000? It's always good to know, because then you always can plan. When you know that your system usage is going to spike, you can always work with and kind of put in these solutions beforehand, rather than running into it when 1,000 customers come online at the same time and hit your system. So these are some of the tools that I've listed out. JMeter is like the really popular one. You can configure that in quite a different ways. And it's also free. There's also like open source. JMeter itself runs on CLI, but there's open source like a UI that you can use on top of it to visualize the test results. It's not very good on the UI, but the test itself is very robust. You can use something like BlazeMeter to actually run JMeter underneath and just completely see the UI in a different light, because BlazeMeter will bring its own UI, but will interpret all of the data from JMeter. So that's useful. And if you know Grafana, so these are the same people that have all these other time series databases and the viewer. And they also have a K6 product that they use for load testing. And then Gatling is another one. There's actually so many, and they're all they're all available online, and some of them you can run on your own machine, some of them you can run from their servers. BlazeMeter, for example, has, I think, up to 50 users free to test. So it's not like, something that will cost you money to get going with. You can test it out, see how things go. So what I did was I set up a couple of tests for BlazeMeter. I'm on the free plan, so it doesn't really cost me anything. You can essentially just set up the URL here. It's very simple. Just set the method as well, and then you should be able to. I think you just need to expand this, but once you set the URL here, you just tell it how many users it needs to be hitting. So the free plan gives you up to 50 users, and it shows you how it will ramp up. So this is important because you can test different things. So the duration of the test itself is how long it's going to be running. But the ramp up time here shows how those users will show up to your site. Are they going to all show up at once, so that you just go from 0 to 50 at once? And that might also be a scenario because 50 users is not much, but it's unlikely that you're going to get hit with like 0 to 5,000 at once. So those generally would have a ramp up time, and you can set that as well. I've tested on BlazeMeter open source up to about, I think, 5,000 users. So when you do have that kind of concurrency going on, you generally want to test this on separate infra. Do not run this on your local machine because it will eat up all of your bandwidth, because you're also hitting sites with a lot of traffic. So make sure these are your actual sites and not some random site, because BlazeMeter creates infrastructure and then sends these requests out. So if it's a very low performance site, it can go down. So make sure that you're testing your own site and not anything else. You can then also set options on the locations, because sometimes you want to check, for example, if your servers are in US East, you can check from, say, Singapore and see how the performance is with that kind of land. So that will have a ping built in, and you can test for that as well. You can also set a lot of test data. You can test for multiple requests at once. You can build in that behavior of how an actual user would behave, and put it into your testing suite. So every time you do a release, you see what's going to be happening. So I actually put in a couple of tests. I'm just going to open those up. So this is the last test that I ran an hour ago. So my application with the bad choices in there is as doing about 25 virtual users concurrent, and is serving at about 2.58 seconds. So that's not great. I mean, it is a simple API, but again, I'm running on like a micro instance on AWS, so it's fine. But I think given that there are bad choices, we can probably make them better, right? So if you start going and fixing things, and then in your next release, you can basically measure how well the system is doing, because things that you're working on, you want to see whether there's any kind of improvement. So here, this is after the improvements. It switched from 2.5 to about 1.5. And then on the 90% response time, 1.8, which is really good. That means 90% of requests have been served at about 1.82. And again, this is with the ping. It's still not great, but for like a regular app that is running on micro instance, we've now saved 1 second by working on some of these errors and bad decisions that we made. And you have these load tests to prove that the system became faster. So when you're speaking with your PO, when you're speaking with your CTO, you have measurable proof to make sure that they can buy into these decisions that you're making. So that's important, because you're basically getting all your stakeholders involved in the decision making, and you have these metrics, and they actually have an executive summary as well, which is very useful to have, because you can just send this to your CTO. You can tell them how the system is performing, and over weeks with your work going in, you can show this is all the improvement that you're doing. The system is improving this way. So these are useful things to have. And I think like, this should be part of your core kit. So that's on the load testing bit. So now we know when we run the system, we know the current status, and when we start working on things, we can know how it is improving. But then the question is, how do you find out what to improve, right? So that something that I use a lot, and something that I really open up the moment things just don't make sense, is the Xdebug profiler. So I don't know how many of you have used Xdebug for Xdebug itself. If you haven't used Xdebug, first I would recommend that you set up Xdebug and start playing around with the debugging. If you haven't used debugging yet, then that's definitely your first step, because it should again be part of your core kit. The profiling is an offshoot of that. Basically tells you when it's running through each method, how long it's spending there, how many times it got called, what's the memory usage, and things like that. That's all very, very useful information. But it comes in this kind of format, which is not great. So, second. So the output of that, so I've just set up things on my end so that it generates the, hang on, let me just gonna hide the, yeah. So on this side, let me just quickly see whether I can fix the problem with the, yeah, so I think it's just leakage to resource. I think I introduced a bug in the code in the middle things, but that's okay. So there we go. Okay, so I'm running on Laravel with the debug mode on. Again, if you're working, make sure you switch these on. In Laravel, it's generally just the switching the environment to local and debug on will give you this kind of information. So this is kind of like Xdebug as well here, but it gives you the stack trace. You should be able to read, the stack trace here, and now it shows me exactly where the problem is. So it's telling me that I have trying to read a user ID on int. So if you try to debug into this, you probably find that there is some kind of issue here. So I'm just going to fix this error quickly. Should be part resource. And I'm just gonna return the user ID here instead of creating the full object. That should fix it. Again, because of this kind of debug information that you're seeing, it just makes it very easy to fix these bugs because you're right there immediately. And you know what? I'm just going to return because I don't want to look at this problem anymore. So we'll just set this to null. Now, if you're working on some kind of a PHP framework or like a pure PHP framework that is in there and it's not giving you any kind of information, then that's where Xdebug comes in, where you can go ahead and start going step by step and fix the problem. So here, it was easy enough for me to fix it. So now the API is back in track. And now I'm going to profile it and I'm going to see what the system is doing in the time that it's it accepts the request and then sends it back. So if you notice, I'm adding Xdebug trigger to the URL with 1. And that's a specific setup that I have set up on my end. So on the PHP side, I'm running Apache here just for ease of use, but generally you can do it with whatever you want. But what I've done is that I've set up Xdebug on my end, and I have set it up to work on trigger, and I have set it up to work for profile. So all of this is very easily done. There's tutorials on Xdebug and setting things up. But if you do have problems, just reach out to me. And of course, you can take this project and set things up as well. So once you have set this up, and once I add the trigger, which is Xdebug trigger, the program works as normal. It is a little slow because what it's doing is Xdebug is actually running that profile on the background, and it puts out this file. Now, this file is a big file, so I'm not going to try to open it here. But what is actually collecting is all of those metrics on the method calls. You're not going to be able to make sense of that in raw terms. So we use a program for that on Mac. So the power went off, so it will be back soon. We are in Sri Lanka. So I'm on Mac, so I use a program called Grind. Just going to open up my application. So, and storage, profiler. So I'll just open this up. And now I see all of the information that all of the method calls that my API call has been doing. So if generally it's going to be a little complicated, but once you start working with this and once you start, your application, internally what is happening. I mean, hopefully you do. And then things start to jump out to you, right? And you can switch this to focusing on memory or time. In our case, we're just going to be focusing on the memory bit, the time bit. But if you feel like your application is taking up a ton of memory somewhere, then again, you can use this as well. So it's not a problem. So I'm going to start looking at what do these mean, right? So this basically shows you how much time is spent inside this method in the method itself, and how many times it was called. And then you basically have the function itself, right? And the included here basically means how long did it spend inside, plus all of the the chain that it called, like that method called. So what I want to do is find out where most of the time has been spent. Okay, so I sort by self, and I get cycle 3, cycle 1. So these are basically unknown methods. So we're just going to click on them to find out what's actually going on here, right? I'm just going to make sure I'm on the correct branch, because I have a good branch and a bad branch. I'm actually on the bad branch. I'm on the good branch. I'm just going to check out the, okay. All right, I just switched to the other branch. I'm just gonna see if I can quickly make the call, because I have two branches of one that is good, like the fixes have been applied, and one that is bad, where the fixes are not applied yet. So it's easier to see what the problems are on the branch that haven't had the fixes applied to them yet. So just loading it up. Okay, it's done its thing, and I'll just load up the cache grind again. So 19. All right. So here all right. So now we see clockwork method is getting called quite a bit. And I know what clockwork is. Clockwork is a debugger, not a debugger, but like a information collector library that I added to the program, because it shows me information on what ran in the Laravel request in the console, on the Chrome console. So I can basically then see things like this. So close that. So all of this information. So this is actually giving me information on, what's what queries are running, how much cache models are, all that information. But the thing is, this is slowing things down a little bit because it shouldn't be run on production. So as a mistake, I have left it on and I have been running that in the background as well. So I need to make sure that I disable it. So if you're the person who's dealing with, the speed up work, you just go run cache grind, you'd find this problem. So here I'm just going to put false, and in the next run, clockwork will be disabled. So that would take care of these two because it's not spending a lot of time, but it's still getting called like 6,000 times. So it's quite a bit. Then we look at this, the next one. So it, again, like I said, this will look confusing to you because this isn't your application. But if you were running this on your application and running on a framework that you're used to, you would immediately find information on which methods are causing like the trouble, like which methods are taking too long. For example, I see this and I immediately know what the problem here is because I have two preloading attributes on the message model, and they're appended to the model regardless of whether they are requested or not. And every time I load the message, it basically loads up the count of hearts, and it also loads up the recent hearts. Both of these are loaded by the get attribute method on Laravel, and then appended because I make sure that it is appended. So this isn't really great practice because here you should be using caching. You should be not loading it if you don't want it. But I'm forcibly putting in these errors so that I can go ahead and then go debug them. So then you see this, you generally know that's the problem. And then you can keep going down this layer and then keep finding errors that you think, or like not even errors, but like areas you think you can improve the application, because it just is so easy to actually find out what where is spending time. So as an example, we're just going to go into user controller, and we're just going to do this. Okay, we're just going to put a sleep here of say 2 seconds, and we're going to call the method with the xdebug trigger. So it'll be users. Yeah, it'll be users and then one, and then I want to the xdebug trigger. Yeah. And I'll just set that to 1. So it actually gets cache grind. So here it's going to wait for about 2 seconds, and then it basically loads the data. So now the application itself is not really slow here, but you left in like a, we can say we've accidentally left in a sleep statement, which is slowing down the application. And you basically then open up the cache grind again, and then you sort it by time, and you immediately see it. That's how easy it is to see, and it shows you where the problem is. So you can see that it's been only called once. So you really need to look out for methods that take a long time to process, but have been called a very few times. So PHP native functions like anything that you use like count or array merge, all of those things, concepts that are used in your code are going to show up here, but they're not going to really take time because they're very fast methods. But any code that you put in that doesn't get called as many times, but does take a lot of time, those are the things that you need to look out for. And those are the things that you basically make sure are there for a reason, right? So yeah, so that's profiling. It basically, like I said before, yeah, my laptop is a little slow with Zoom. So it's basically there to really help you find out what your application is doing. Just spend the time to set up xdebug, and just make sure that that is available for you, because it's going to save you so much time, and it's just going to make life much easier for you, right? So next one, the slow query log. This is again one of those things that I find surprising that a lot of people don't have, that a lot of people don't use. So I think this essentially is a configuration on your MySQL setup that enables slow query log and outputs slow queries if they are slower than if it takes longer than this much time to process. And ignore this bit. This is just to show, the setting is on. So I'm just going to enable the slow query log. It is already enabled on my end, but you can run it for this current instance as well. Or you can basically update your MySQL conf and go ahead and make it on all the time. So for now, I just set up the log. It just goes here. I've been running a couple of queries. So the log actually is going to show up like this. So it is a little hard to decipher, but you can see that what you can do is you can start filtering. So there are tools available that basically will filter this information for you. So what you then do is just copy and paste this into the web tools as well. You copy and paste this into the tool, and it will tell you how long each query is running, because you get that right away, right? It gives you the time, it gives you the query time, and it gives you the log time and the rows examined. So these are really important metrics, because when you're writing systems, if your query is taking not only taking a long time to process, but if it's locking tables, that means nothing else is right into that table. And that's a problem. If your query is so slow that it basically locks up a table for 1 or 2 seconds, everything is just waiting there. And if you can't have more than a couple of customers online at the same time, because MySQL is just waiting for the slow query to run. So this is something that you should have enabled, but make sure you don't willy-nilly enable this on production, because depending on how many results you're getting, depending on the log size, a lot of these factors, it can slow down production as well. So make sure you read the configuration. Make sure you set up a good threshold for the query. And because, for example, obviously, if your queries are more than 4 or 5 seconds or 10 seconds, whatever the slowness that is introduced by adding slow query is not going to matter compared to the gigantic 10-second query runtime that you're running already. So that's the problem. And then finding out slow queries, this is the solution. Just make sure that you have this enabled. If you're running it on local, it's a good idea to just keep it on local. Make sure you're working with proper data sets, and then find out, okay, this query, after every feature, just have a look at the slow query log on your system, just to make sure that there are no really big queries that are problematic. And this tool will help you with that. Again, I think services like AWS, RDS have these enabled. So you can have these features enabled without too much impact on the performance. Again, just gives you a lot more insight into what is going on. Yeah. And then once you know that there is a slow query, how do you find out why it's slow? So again, these two tie in, and this is again one of those really integral pieces that you really want to know and should have right from the start. Is basically the Mysql Explain is literally just the explain keyword in front of a query. There is no magic at all, but it's not a lot of people use it. It should be your first thing in your kit whenever you're examining a query and trying to find out what's wrong. Most people jump at indexes, and usually you are right, but you need to look at which index, why is it not using one index over the other, how many rows, how many indexes, how many sets of data sets is it examining. All of that information is given to you by the explain. So I have a method here basically that gives you the most posted, and I can't click on the bottom because it's Zoom. All right. Yeah, with the Zoom, it's just kind of slow. Okay, well, it's not responsive right now. Just gonna click on the live example. Just get this out. Yeah, there you go. So we'll run this. And now this query is not like something complicated. It basically just looks at hearts that were, sorry, this is the other method. So this basically looks at users who have posted the most given a date range. I'm not, yeah, so my page is unresponsive with this, but just gonna exit that. Zoom is a bit of a killer. So don't worry about the API method itself. It's again, one of those things that are fairly simple. So I'm just gonna switch over to the branch. Main, and I'm just going to open up user controllers. Yeah, so essentially it's fairly simple. Looks at messages, looks at when they've been created, groups them by the message ID so that you know how many messages were posted by each user. And then you sort it by the most posted to least posted, and then you get the top 5. So you end up with 5 users who have posted the most amount of messages during that time period that you give. The resulting query itself is basically this, the one that I had in the. So this query looks on the surface fairly straightforward. And again, if you actually run it on the local machine, it's instant, takes 0.02 seconds. So that's fast. Again, system shouldn't have any problem. But if you do an explain, you're gonna see something here. So again, it tells you what the select type is. For us, it's a simple select, and it gives you the tables that are being considered. And then you have the keys, the key length, useful information. The one that you want to focus on is the table and then the rows. So I told you earlier that the messages table has about 5,000. So here we are seeing that it's basically scanning, and the rows are basically the column that says how many rows were examined by the query planner. So the query when running scanned 4,800 messages. So that means it scanned like I think 99% of the messages in the system. Now, it's not a problem when you have 5,000. MySQL is able to handle gigabytes and gigabytes and gigabytes of data, huge data sets. But this might slow down if you had 10 million records, because it would have to then scan 10 million records, and that takes time. It could take a second, could be 2 seconds. And if you had like 100 million records, it could take a while, right? So the problem here then is that the system is going to work now in your initial data set, but a year down the line, this method is going to kill your server, because it's just going to time out after waiting for 30 seconds or whatever your timeout period is. And in that period, a PHP worker thread is basically locked and there's nothing else going on, right? So it's you might have left the company, you might have gone on and you'd be doing something else. The new person coming in is going to have to deal with this problem, and they're not going to know anything about the method. They're just going to look at what the problem was, and then they're going to be like, this method is taking a long time. And if you run an explain on this, it will be immediately apparent what is going on. So here, the problem is that it's just using a where. There is no key being used here. And that's the problem. I think most of you, if you came through like the formal learning route, you'd be taught that you want to have indexes, and people realize that they need to have indexes. But the problem is that most people don't realize how to see whether the indexes are being used or not. And explain is the way to do that. So if we take this query, we're just gonna do one thing to improve it. We'll just add an index on created at, because that's what we are actually using to improve. So we go ahead, now we've added the index, we run it. Hang on. We're running it on messages ID, messages created at. Did I? Oh, I think I added it to the messages, sorry, the user structure. So yeah, created at index, SQL. Yeah, and then we run it. And now it's dropped from 4,800 odd messages to 776. And it's filtered, and it's using the index condition, it knows. And that's a massive gain. That's a huge gain, because you can see here that is using the created at index. So you know that the index is used, and it's also telling you what other indexes are available. Like, for example, if you look at the users, because this query basically joins with users. The user table has the primary key because we're looking on the user ID, plus it also has the user email unique, because the emails need to be unique. So that is an index in itself. So when it joins, when it's picking up these users, it knows right away, because when we're grouping by email, it doesn't need a separate index. It basically will be just using the email unique index. And yeah, I mean, it's as simple as that, like, you know, just the fact that, you know, whatever large query that you're using, you can just add explain in front, and you're just going to be immediately, you'll be able to immediately see what the problem is. So this is also very useful to figure out the performance benefits of one query as opposed to another one. So if you have two approaches that you can use, for example, here I'm using groups. Here the group is kind of required, but generally, if you there's a big trade-off between groups and joins. So if you're using, for example, only like if you want to see the performance benefits of using the group as opposed to a join, you can use this explain to see what indexes will be used. Do we need to add more indexes to use them, and which index is actually more performant? Because, as you know, as you add indexes, things will slow down for creates, reads, and deletes, and it will also take up more space. So using the correct index and making sure if you can use an index that is already there, those are all performance decisions that you need to make with all of the knowledge available to you. So these kind of tools will basically help you with that. Yeah. So I think that's it. Like, that's what I really wanted to share. So those 4 areas, just going back, basically we want to look at load testing to find out how well a system is doing, and to measurably communicate how well it's doing after your changes. Is it doing better, or is it doing worse? How is it better or worse? And in what key metrics? The Xdebug profiler basically gives you information on the internals. You can find out, when you're going after a problem, you can find out what the problem is by looking at the profiler output. Just make sure you don't do it, while you're running Zoom. It will kill your system. But otherwise, it just makes it much easier to find out the issue. And really, it helps you find these issues out when you've done silly mistakes, because that's the one that is really best at, because you've accidentally left a debug line or something like that, or something. It basically helps you find that and the problem, and then zoom in on it. Then the MySQL, on the MySQL side, slow queries and the explain keyword helps you make sure that whatever SQL queries that you have are running well. And if you don't have the slow query on, you won't really know what your system is doing on the SQL side. It could be taking up a lot of time waiting on a query. And unless you use something like the profiler to find out, this method is actually taking a long time, is going to be problematic because you can't run the profile on your production system. I mean, you don't generally want to, unless it's with like a trigger or something like that. But the slow queries are just a much easier way to deal with these things. So yeah, those are the topics that I wanted to talk about. Just some beginner-friendly topics just to help you find out, like, the problem isn't actually the application itself, it's just that the techniques aren't being used, especially when there are so many tools available. So every one of you here will probably have different problems, and this will be very unique to each of you. So I hope that the tools that are being introduced and the commands that are being introduced here will help you to go ahead and then find out what your unique problems will be, and then go and fix them from there. Thanks. Zara?
Yeah, thanks, John, for the session. And now I would like to open up the floor for any potential questions that you guys might have. We'll be using the next 10 minutes for a live Q&A session. This can be on anything that you might have had in mind during John's session and the session that he did earlier as well. So please feel free to drop your questions into the chat box, or if you would like to drop them into the Q&A section, you can do that as well. We actually do have a question that we have had coming in during John's session, which is, what is your IDE? Is it PHP Storm?
Yeah, I use PHP Storm on the Mac. It's pretty, it's very well integrated with all the tools that I use. Unfortunately, it is paid, but they do have student licenses and things like that. But if you can afford it, I would say definitely check out the tool. It's a little big because it's not as light as say Visual Studio Code. But because it becomes built in with PHP and all of the tools around it, it just makes your life easier. I, of course, use VS Code as well. I use it on my Windows machine. I use PHP Storm at work, and then VS Code for my kind of hobby projects with the PHP extensions enabled on it.
Thanks. Hope that answered your question. And like I said, we are holding the next 10 minutes open for any questions that you guys might have. So do drop them into the chat box if you have any queries that you would like clarified.
So I think, yeah, the end is usually a little bit of a wait for questions and things. I think something else that I want to mention while there are questions, anything if anything comes up. Just checking. There's so yeah. So basically, if you want to use Xdebug, make sure you set up the different modes. It can run in like a profiler. It can also run in the like develop, and then also the debugger mode. It also has an interesting option so that if you're using PHP, if you use the var dump method, it can basically make it a lot richer. So it gives you a lot more stack trace information. And it can also protect you against things like an unlimited, like a recursive call that goes in too deep. So all of those options are available, and then you can kind of set them up so that it works with you. And then, for example, like, I use debug quite a bit. Like, it's not set up on this project, but all you had to do is, if you want to just have the system stop here, you just set the breakpoint, you run the code, and then it stops here and it tells you what are the values for this, what are the values for this, and then you can basically just step through the code, and then it gives you all the information on what the system is doing. It's a lot easier than just going and using something like, I mean, in Laravel, I think we use the DD method quite a bit. So quite useful there. What are the tools that can be used for formatting the log data? So for log, at our company at Rentman, what we use is CloudWatch. What we have is, so I think on PHP, we use Monolog. For Monolog, we just set up like JSON-based data. And then when we push it to CloudWatch, as long as the data is not too long, because they do have a length limit, as long as the data is not too long, you can then use CloudWatch metrics to search inside the log data as JSON, which is very useful for us. And I think you can also use things like, I've seen people use Elasticsearch when you have like a lot of log data. With Elasticsearch, there's a tool, if I remember, I think it's called log format or something like that, or I don't remember the specific one, but it's part of the ELK stack, ELK. So Elasticsearch is the E part, and then K is the Kibana part, and then the L one, I don't remember. But it allows you to transform the logs the way you want it. And that will help you to format it, and you can dump stuff that you don't want to log and then move them along. Hope that answered your question.
Thanks for the question, Nishanta. Wow, it seems that there are quite a number of questions coming in now, as it usually does. The next question that we have, John, is are you using Docker-based local environment or any other alternatives? That is the first part of the question. We'll jump into the second part once John has answered the first.
Yeah, for local, I just use Docker. It's just much easier. So on the Mac, it basically is a native Docker. Zara, my screen is still shared, right?
Yes, it is.
Okay. So I just use it here, and then everything is on Docker. So I have like all of it running in here, and I just use Docker Compose. It's just much easier to work with. And then on Windows, what I do is I use the WSL2. So that's a Windows subsystem for Linux. It gives kind of like a, I think most people tend to use the Git bash for Windows when they want to run Linux commands, because it's kind of like a close approximation. But you should try out WSL because it allows you to run a complete Linux installation inside your Windows, and you can just access it as your command line. And then on top of WSL2, I run Docker, because then it just becomes much faster. That's what I use for local. And for the plugins with PHP Storm, there's not plugins and stuff for PHP Storm, because PHP Storm is, the reason it's paid is because they've made a really well, like a cohesive editor for PHP. So there's a lot of plugins already built in. I've actually not had to install anything on PHP Storm, but on VS Code, I run the Laravel specific extensions. I run Prettier for the JavaScript code formatting side. I run all of the integrations with the remote coding, because then I can code on VS Code, and then the code itself is running inside Docker. And then all of the regular PHP extensions to make the VS Code work with PHP. And next question is raw Curies and Eloquent. Yeah, I mean, this is preference thing. Laravel is, Eloquent is actually one of the better ORMs that, not an ORM itself, but like it's just one of the better, I guess, like query libraries that I've worked with. It really does put out queries that are really close to what, I would type, what I would write out. And for me, generally, like I have, PHP admin or some kind of SQL client running all the time, because I start with a SQL query on my end, write out whatever I need, because I use the explain quite a bit. I make sure that, the queries that I'm running are performant. And then once I have the query and once it's running, then I either I map it to Eloquent in this case, but like I don't actually work with Laravel at the, at Rentman. We have like a custom library, custom framework, and there we basically have most of the queries kind of mapped out almost directly with a few wrappers in there. So it's close to very like raw queries. So generally, I just like working with that. But yeah, as a preference, I work with raw queries because I know exactly what is going on. Even if I write a query like this on Laravel, I just make sure to do like query at the end to make sure that the query that is generated is what I wanted. I always check, because otherwise you don't really want Laravel to, or anything else to, do things that you're not intending to. And other than MySQL index and other configuration, do we have any useful method in PHP Laravel to increase the performance when we are about to retrieve data from DB? Yeah, I mean, on the higher end, you can use like a proxy cache. If, for example, you may be running the same query over and over again, and if there is no change, then like for example, AWS has an RDS proxy. You can run one of those locally on your end, like on your production services as well. Those would increase the performance quite a bit, because you're not fetching, it's like Redis for your database, something like that. But I think on the more simpler side, make sure that your MySQL configuration is set up properly. So, that it has enough memory, the indexes, you're using the correct table types, all of that. I think those, like, I would start at that level. So if you look at MySQL itself, there's a bunch of these configuration options that you can set up properly once you've dealt with all of the low-hanging fruit. So I think that's something that I would look at. And any tools or recommendations to debug production-only issues? Finding local staging, but when it's in production. Yeah, I mean, I think, this is a very common issue. And here, it all really comes down to your monitoring. At Rentman, we run Sentry, we run CloudWatch. We also make sure that, because our requests go through multiple systems, so we make sure that we have trace IDs on those requests so that we can trace them across the system. We also run some front-end monitoring tools to make sure that like we do a sample where for certain requests, we also record what is going on, which is useful for us. And in this case, I think Sentry or something similar, and Sentry, to those who don't know, is a monitoring solution that basically tracks the stack trace and other information on the request for PHP and for many other programming languages, and groups them so that when something does go wrong, you see the alert and you know right away what the context of the alert is. This helps you quite a bit, because then you can kind of replay the request to see whether that's repeatable. If it is repeatable, then it should be a simple fix, because you can keep fixing it until it stops erroring out. If it's not repeatable, then it becomes a lot more problematic. But then that's where things like CloudWatch or any other logging service comes in. So it really comes down to how well your metrics are tracked, like the logging and the monitoring. And for production, generally, I would say start out with at least Sentry or something like that, because they have a free tier. And then keep moving on to logging and other things, because you need them for sure. Is it okay to use for profiling New Relic? Yeah, I mean, I've used New Relic before. The only reason I think I don't use it is very expensive. It is very, very expensive. But it is a great tool. It has application performance monitoring, the front-end monitoring, database, infrastructure is all kind of built in. And I think that tool is of a different level than Xdebug, which is a very focused tool. It's it's like a scalpel as opposed to like a Swiss Army knife. And I think the better comparison would be New Relic and Datadog or something like that, because those are all just holistic tools that will monitor all of your infrastructure and everything around it. So yeah, I mean, if you have New Relic, for sure, then that I think works well, because then you don't need something like Sentry, because that will give you that information. And how to identify the memory eating app. It's like I showed earlier, basically, instead of using the time in QCacheGrind, just use the memory. So here it shows you how much memory is being used. In this case, if you just sort this, you'll see that right on the top is the compose auto load, right? And that makes sense, because that's the one that is calling all of the other files. So that is going to use up a lot of memory. So that makes sense. The other one is basically the service provider inside Laravel. Connection factory, yeah, again, it's loading the classes, which again makes a lot of sense, because those are going to be like the heavy ones. So in here, then you start looking at things that like this actually doesn't have any kind of memory issues, because if it did, I wouldn't be able to run it on a micro instance. But if you did have any kind of problems with a lot of memory heavy apps, it will show up here where the self memory is very large. And it would be like a big chunk. So yeah, memory or time, both of them show up with the cache grind. Cool, thank you. And yeah, is that it? Any other questions?
Looks like that's it for the moment. Please do feel free to drop in any other questions if you do have any, either into the chat box or into the Q&A. In the meantime, thank you so much, John, for spending your time here with us today. It was quite an insightful session, as evidenced by the number of questions at the end of it as well. And of course, big thank you to our audience for spending your evening with us. I've also linked in the PHP Developers Sri Lanka group in the chat. So do join that group to stay updated on future sessions and future events that we will be hosting. We have something coming up next week as well. We will be hosting a session on Python and fast and easy machine learning. We will keep all of you updated on that as well. And once again, thank you, John. Thank you, everyone, for joining us today. Have a great evening ahead and have a great Friday and a great weekend ahead as well. Thank you so much, guys. Have a good night.
Thanks, guys. Have a good night.